Okay, so now we have jog animation, walk animation, and crouch animations. Now let's add a sprinting feature for our game. Okay, so uh, I think it would be nice to make our sprint as a general feature, because whenever I start to sprint, it should directly jump to the sprint state, right? And sprinting doesn't need to be triggered for each cardinal directions like we did for walk, jog, and crouch, because sprinting is always a one directional animation, right? Therefore, I don't think it would be nice to move or nice to implement the sprint logic at the movements group. Instead of that, let's implement at the uh, general category. Okay, so let me quickly look at my documentation. Okay, so here we are. Right, so let's go to the SNM general category, and here we need to add sprint, right? But first let's create a new blueprint structure called SNM sprint. Okay, then we see, right, let's add start state, which is anim sequence, and cycle state and stop state, right? So these shouldn't be cardinal direction based animations, right? So as I said before, sprinting is always a one direction animation. Therefore, we don't need to impose pivot anim sequences here as well. But the sprint animation may modify the movement configurations, such as the movement speed or maybe acceleration, things like that. Therefore, we should have the movement config here. So I think it is anim config. Yeah. Right, now we can configure the walk speed, acceleration, things like that. And then let's assign this to the anim general category. I'll mark it as sprint. And the data type is anim sprint. So if I go to the dt anim set data table, now we have a new record called sprint. Okay. So I think we don't have animation for the start and stop anim sequences at the Lyra, but the Lyra provide sprint forward animation. So let's add that sprint forward to here. And if you have like customized sprint animation, maybe you can create 3 different animation for start, cycle, and stop, so it would be pretty much nice. But I think in our scenario it would be enough to have a cycle animation as well. Okay, and for the walk speed, I'll make this as 700. For the acceleration, make it as 1024. And also I think for jog as well, the configuration should be 1024, because 1500 seems bit much more for the jog acceleration. Okay, now we have the animations, we have the configurations. Now let's go back to the ABP locomotion. Right, so if I compile as I expected, it gives the error. So I think yeah, did I change something? Yeah, I think first we have to go for the component level and compile it again, and it gives this error back. Because I forgot to save this thing actually. So let's how to resolve this. Yeah, so let's go to here. And let's refresh not so it will break the pins. Now recompile and assign it back. Why it doesn't give me this thing? Okay. I think there is a sort of a bug. So let's try to open it again. Yep, it's pretty much broken. What I can do is I can plug this again. Maybe let's manually assign the data table. Right. Oh. So if I had a boolean, actually it gives. Let me save it all. Let's go to the component level again. Get the anim set function again. Why it doesn't show this thing? Yeah, maybe let's restart the editor. Yeah, just restart the editor, but still the error is there. So I found the issue actually. This sanim set data structure has been broken, and that's the issue. So I think we have to fix this thing. So the easiest way to fix this one is, let's first so the anim set general has been compiled properly. So let's mark it as boolean now, and let's reassign the sanim general and save it. Okay, now it is not broken and good to go. And let's go to the data table again, save it back. And I suppose all of our stuffs has been lost because we have been reset it. So let's reassign those real quick. Crouch entry, crouch exit, sprint. That's 700. Okay, now let's go to the component level, and as the return node, let's try to reattach the anim set like this. Okay, now that reference has been done, and plug it to here. Okay, so I think it's a very crucial thing when it comes to these structural changes at the data structure level. Make sure to save properly And before directly jump into the compilation of your component, make sure it is marked as good to go. Otherwise, these sort of issues could be happen. But I think it's good to have that error right now, because in case if you face that issue later on, now you know how to resolve it, right? So it's a bit tricky to tackle those sort of issues, but yeah, that's how we resolve it. Okay, now we have those stuff at here, and we have resolved the BPC locomotion component as well. And I think now we can go to the ABP locomotion level and compile, and now that error has been gone because ls and imset has been now set up properly. Okay, and then I think we don't need to have a separate state called sprint at here. Instead of that, we can override the state values of these existing states, because the sprinting can occur at start state, cycle state, pivotal state, or a stop state, right? So I think we have to manually attach those stuff at the proper places. But first, let's capture those values at our thread save function set animation data here, right? So like we did in the idle stances, I think we can copy the same thing, and let's get this print, break it. Let's promote this to a variable, and let's mark it as sprint start. This one is sprint cycle. And finally this one is sprint stop. Let's assign it to here, and I'll collapse these nodes and mark it as sprint. Right, those are the three variables that we need to capture. And then what we can do, right? So this start and stop state can be empty, like we mentioned here. So in such scenarios, it should point to the existing cycle state, right, in order to prevent such T-posing issues later on, because these states can be null. So what we can do is, let's add a sequence, and let's see if our sprint start is not valid, right? If it is not valid, then set the sprint start as sprint cycle, right? So similarly for the sprint stop, if it is sprint stop, if it is not valid, then set the sprint stop as sprint cycle. Okay, not the sprint cycle actually, right? That's wrong. I think we have to get the start cardinals, break it, and the forward. This is the proper approach, right? Because either of these three variables can get null, right? Let's say in case if we haven't specified a sprint cycle state here, so this can be null. So in case if it is null, instead of moving to the sprint variable, we can simply set it as cardinal forward value, right? So even if I try to sprint, and if the sprint animation is not present, it will simply play the forward cardinal direction animation. Okay, similarly to here, we can get the stop cardinal forward, and I think we may need to add one more pin after this, and I'll copy the exact same thing to here. And for the sprint cycle as well, we can use cycle cardinals forward and say the sprint cycle. Okay, right. Then what we can do, right, now we have those variables set up here. Now we can go for anim graph, and yeah, let me quickly look at my documentation. Right, so at the start, so here basically we are setting we are setting the start animation based on the cardinal direction, but let's say if we are sprinting, then instead of this forward animation, we should play that sprint any. But I think still there is no way to determine whether we are sprinting or not, because we haven't captured any character state data, right? So let's capture that thing, but before capturing it, I think we may need to implement another event dispatcher, right? So let's go to the BPC locomotion system component, and let's add a new event dispatcher called event on sprint changed. Okay, and let's add a new input called is printing, and this should be simply a boolean. Okay, now we can listen to this event at the ABP locomotion inside initialization, and let's I think we can organize these pins a little bit. Like this. Okay. Right. Right. So similarly, let's set a new bind for the sprint changed, and let's create an event Okay, and let's create a matching event, and I'll rename this as event on sprint changed. And as usual, let's move this to the event graph, locomotion event graph, and this will break this signature. So let's assign it to the event on sprint changed function again. Let's compile. Yeah, now that issue has been gone. And here what we can do is basically let's go to that function again, and we can simply promote this to a variable called isPrint, right? And this is a character state data. And since this is a state change, we have to set the animation data again, plus this should capture this sort of a instantaneous change. So let's add a new one called sprint changed and assign it to the character state data, and I'll set it here and wait for random, not a random but a 0.1 delay, and reset it back to false. Plus I think I can move these to the anim sequences category. Compile, save all. Right, now the state change has been captured. So let's go back to the our setup start anim layer, and here let me see. Give me a second. Yep, here let's set a select node based on this character state data. So if you are sprinting at the start anim, you can show the sprint start, and if you're not sprinting, you can simply show the forward anim, right? So this is for the start, and similarly I think we have to go for the cycle as well. So anim graph, locomotion, cycle state, I update cycle anim layer. Here also we have to add that change. Select, if we are sprinting, show the sprint cycle, else forward anim, like this. And for the pivot state, you don't need to do anything, right? But I think for this stop state we may have to do some change. Yeah, for the stop state at the setup stop anim layer, we have to select, right? And if we are sprinting, we have to show sprint stop. If not, we can show the stop cardinal anim, right? So if I brief it back at the start setup start anim layer, we have this one. Let's move the nodes a little bit. We have sprint start, and at the cycle we have sprint cycle, and at the stop we have sprint stop. Okay, great. Now if I play a test, it doesn't work because we have to provide what we have to provide input action as well. Okay, so let's create an input action real quick. Let me see. Yeah, inside the character, let's set a new input action called IA sprint. Right. Let's assign two triggers. One for pressed and one for what? One for released. Right. Then let's go to the input mapping context and add a new mapping for this IA sprint, and I'll use left shift. Right. Okay. Ignore these for now. Later on we can resolve those validations. Okay. Now what we can do is now we can go to the player base and let's call that function. Right. Input action actually. So IA sprint. So if we are pressing, we have to sprint, and if we are not pressing, which means we have been released it, we have to stop the sprinting. But why it doesn't show that released thing here? Okay, pressed and released. Let me quickly see. Yeah, we can use started and completed for sprint true and sprint false. Yeah. Now what we can do is okay. So first let's add some printings. Sprinting here. Stop sprint. So let's play. Yeah. So now that input works, but we should do the transition properly. Okay. So how to do that? Yeah, I think Yeah, think we can go to the BPC locomotion system and let's set a new function called, what variable, it should be a function called set, right? And here let's get the input is printing as a boolean, and if we are printing, let's promote it to a variable called is printing, and then we can call this one, right? So if you are printing, simply calling, setting this value and calling this event dispatcher, and this event dispatcher will listen to that event and trigger this action, right? So now let's go to the BPC player again and get this thing, and let's mark it as true if you are sprinting and mark it as false if you are not sprinting. Okay, and let's see. Yeah, actually now it's working. You can see the transition happens. The animation is playing properly, but not the animation speed. So if I go to the data table, yeah, it should increase the work speed. So I think the issue is at yeah, we haven't checked this set moment config function. So whenever we are sprinting as well, we have to set the moment config, and I'll move this function to set as category. We now play. Yeah, it seems one is applied, so let's print it. Yeah, it is been applied, but the speed is unnoticeable. Let me debug. Okay, so I found this actually. If I try to print the walk speed, you will see where the issue happens. Okay, see, now if I'm jogging, the speed is 500, and if I try to sprint, it still print as 500, right? Which means the returned value from this function is wrong. And let's see why. Because here we are getting the speed configurations from the movement component, right? But ideally we should get the configuration from this general category, because the speed is under sprint is under this general category. So that's the issue basically. So we can resolve it real quick. All we have to do is make a selection here. Or it would be clear if we make a if clause here like this. So if we are sprinting, then we can return this configuration that has been taken from this print, right? But if we are not sprinting, then we can return this configuration, right? Okay, now let's see. Now you can see the sprint is applying proper. I think maybe we can increase the walk speed like 1000, and let's keep the max acceleration as 1500. Yeah, now you can see the sprinting is working properly. Okay, right. Plus maybe we can improve the transitions as well, but first let's remove those print statements that we had before. Yeah, not here actually. I think one of the print statement is at the set moment config, and one of it should be at where. Yeah, not here, but player. These two we can remove, and instead we can simply plug it like this. Okay, now we have a sprint, and we can do sprint from these different movement types as well. Okay, great. Yeah, I think those are the improvements that we can implement to add sprinting features for the project, and maybe we can improve some of the transition logics at here as well, because now we have set of new character state data. So based on those character state data, maybe our transition logics can be further enhanced, so we will be having much more smoother transitions, but we can do those optimizations later on, and for now I think this would be fine. And yeah, so I'll see you in the next tutorial. Thank you.